Hey, that works. That works much better. All right. Thanks, that Mary. Um, okay, so welcome everybody. My name is Wyko, and today I'm going to be talking to you about reactive programming, and specifically the reactive journey that I went on together with my team. So first, I want to do a show of hands. So who's already familiar with reactive programming? Okay, and who's actually applying it at his job? A little bit less, but still. Um, So what I want to do today is do a quick recap on what reactive programming is and why we would want to use it. It's not going to be a full introduction. There are other nice talks for that. Then I'm going to be talking about what a reactive JVM app consists of. Then I'm going to discuss a real-world example of a reactive application that I built together with my team. And I'm going to finish up with some tips that you should consider when you start doing reactive programming yourself. So what is reactive programming? Well, Wikipedia has this nice definition of it being a programming paradigm concerned with data streams and the propagation to change. However, in my experience as a Java backend developer, it kind of comes down to this. It's just writing asynchronous non-blocking code using reactive APIs. And I want to go through what this means by first kind of getting into what asynchronous non-blocking code actually is. So let's look at some code. First, some synchronous old-school blocking code. So think of a scenario where we want to get a product, and we get an offer, and we want to combine the two. And these are I/O operations. So to get a product, we do an HTTP call to another service. So this code, if we execute it, what does it look like from a threads perspective? So we have a thread with a call stack. And we get a product synchronously, and when that is finished, we get an offer, and when that is finished, we can combine the two. Now, in the real world, we want to achieve concurrency, so we want to be able to get multiple products with offers at the same time. So does anyone have a guess on how we can achieve this? Right, I hear Lewis say it. We simply add more threads, right? And this works. So now we have a concurrent application. However, in modern microservice applications, we're actually doing a lot of I/O most of the time. So this means that most of these threads will be in a blocked or a wait state most of the time. And there are also limits to how many threads an application can actually have, and all these threads take up a lot of memory. So there's a more efficient model for this, and we can rewrite this code in an asynchronous, non-blocking way. So let's do that. So in this code, we get the product and the offer asynchronously, and they return some sort of a future type that's not directly executed. Now let's look at the thread again. What happens when we execute this code? So we start getting a product, pretty similar. Then we get an offer, and then thread is doing nothing, right? So what's actually happened here is that we've just fired off these requests, and now the thread is waiting until the results are actually back, and it gets a callback, and it can do processing on the result. So when the information is returned, we can combine the two, and we can go on. And if we look at this from a timeline perspective, with the synchronous code at the top and the asynchronous non-blocking code at the bottom, you can see that the thread in the asynchronous non-blocking code has a lot of time to actually do other stuff. So while it is waiting, it can actually do other requests and other computations. And this is really nice, because what we can achieve with this, and I'm quoting the Spring team here, is using an asynchronous non-blocking model, we can handle concurrency with a small number of threads, and we can scale with less hardware resources. And that's something I think that we all want to achieve. So now I want to talk about the next part of my definition, which are reactive APIs. So what are reactive APIs? Well, reactive APIs are APIs built upon the reactive streams specification. And the reactive stream specification was basically an initiative, and they want to provide a standard for asynchronous stream processing with non-blocking back pressure. So this talk is way too short to get into what non-blocking back pressure means. But basically, think of it as a set of methods, an interface that can be used to process asynchronous data. You can include this interface as a separate dependency, but it's also included in JDK 9 as the so-called flow interface. But since this is just an interface, you cannot actually do programming with it. For that, you need an implementation of this interface. And on the JVM, there are two major ones right now. The first one is ArcJava. It's developed by Netflix. And the second one is Project Reactor, which is developed by Pivotal and the Spring team. And the main thing that they give you is they give you two types. One is that models a stream consisting of 0 to n items, which in ArcJava is the observable type, and in Project Reactor is the flux type. And one that represents a stream of data consisting of 0 to 1 item, which is a single in ArcJava and a mono in Project Reactor. Now you might be thinking, which one is nice, which one should I choose? Well, ArcJava is kind of the first one. It has a new version out, ArcJava 2. And the nice thing about it is that it supports JDK 6 and up. So you can use it, for example, for Android programming. It's really popular there. Project Reactor is a bit of a more of a modern implementation. It is the basis of the new Spring 5 framework, and it's JDK 8 and up. My experience, if you're doing backend programming and you're not stuck to JDK 6, Project Reactor is really nice. On these reactive types, we have operators, and these operators are kind of similar to the Java Streams API that's included in Java 8. So we have a stream of data, and we can transform it using a map operator. We can transform it using the other asynchronous data using the flat map operator, and we can combine multiple streams together using the zip operator. So now that we've defined what reactive programming on the JVM kind of consists of, let's look at what a reactive JVM app kind of looks like, what its tech stack is. So I want to take the example of an application that calls some sort of product over HTTP, and it applies some business logic over it, it processes it, and it returns it through an HTTP interface in the controller. So in the old blocking way, we would have something like a backspin driver or a REST template as the HTTP client, and to return it, we would use a JOXRS or a Spring MVC or offer it through another backspin driver. But what does the tech stack look like when we want to do reactive programming? So our HTTP client needs to be non-blocking. It needs to be able to handle non-blocking I/O. So we need to use a non-blocking HTTP client. An example of that is async HTTP client or the new web client that's included in the new Spring framework. And our HTTP client at that point then produces one of these reactive types. And we want to apply our business logic to that reactive type, and we want to return it for our API. And for that, there are two ways to do it. Basically, you can use deferred result if you're stuck on an old Spring version. In Spring 5, you can actually return these types directly in your controller, and everything is working fine in a non-blocking way. However, here at Bol.com, we value being resilient, so we need to use HYSTRIX. Thanks, ladies. And that kind of complicates the tech stack, because in our previous example, we were returning a nice mono type from our HTTP client, but because we have to use HYSTRIX, HYSTRIX only supports an old version of ArcJava. So what we need to do, our HTTP client needs to return this old ArcJava type, and then we need to convert it afterwards. So kind of working now, right? Well, there's still one more bit. For some reason, and they give this stupid reason on GitHub, you cannot use nulls in your reactive types. And this is very annoying, especially if you're familiar with Kotlin, that has really nice null safety. You cannot use nulls in your stream. So we need to fix this somehow, because we want to indicate when we do an HTTP call that for example, a product might not be there. We can change this by basically adding an optional in the reactive type. It's not really pretty, but it's the most pragmatic way to do it. So what does the stack look like in the end? So we have our HTTP client producing this observable type because of HYSTRIX reasons, and we convert it to this mono optional, and we return it to our API. So now I want to dive into the real-world example of the App API, which is a reactive app that my team made. What does the App API do? It basically gathers data from different kinds of services, and it delivers it in a handy format to the apps. An important thing is mostly doing I/O. So we're not doing any business logic. That's done by other teams. We're just getting the information over HTTP and transforming it and spitting it out again. This was kind of fun since we started out really small. I saw this old WhatsApp image where we were really proud that we were doing 18 outgoing requests a second. Right now, this is just a part of our HYSTRIX board. We're doing like 5,000 incoming requests and 20,000 outgoing requests a second. So lots of I/O, and all in a reactive way. And I'm going to kind of show a small snippet of what our code looks like. Most of our code is kind of like this. So we get stuff in a reactive format from different services, and we define a feedback, and then we combine them, and we do something with it. And I don't know about you guys, but I think this code is pretty readable. And I think the Reactive APIs really shine when doing these sort of operations, getting lots of data from external services and combining them. However, there are some big gotchas when doing reactive programming, and I just want to go through a few horror stories that we experienced, because there are also definitely downsides. So I want to ask you, can you see what is wrong in this picture, where we do a search for Star Wars DVD in the apps? Anybody? No? Let me zoom in. Anybody spot anything? Well, to me it's pretty obvious. The Star Wars prequels have a higher rating than the original trilogy, which obviously should never happen. That's a huge bug, and we're sorry that we made that possible. But what actually happened here? So we were doing transforming these reactive types, and we were using the flat map operator without properly reading its documentation. So what does the documentation of the flat map operator actually say? This operator does not necessarily preserve original ordering. So what happens? The wrong products got the wrong rating on production. This was not great. We could easily solve this by using another operator, the flat map sequential operator, that actually does preserve order. But main takeaway from this, these operators, they might be familiar to you. You might be already using them in Java 8. But their implementation might be slightly different. So before you start using it, it is worth it to kind of dive into the documentation and look at these things, like what does it do to ordering. Next one. This is a graph of our total memory from last spring, I think. And you can kind of see at the end there that something is happening. Something that kind of looks like a memory leak. Which it was. And when that happened, this nice ticket was created by SRT. App is not working because NAPI is overloaded. Emergency. So what happened? The entire app was down for 40 minutes until SRT stepped in on a Sunday afternoon. Thanks for that. Restarted the server. But we had a huge memory leak, and this was not nice. Turns out we were using a new fancy HTTP client that had a memory leak in it. But basically the main takeaway for me and my team was these reactive technologies, they're still pretty new. and you're just gonna run into bad shit. And you need to be prepared for it. You need to be monitoring closely and looking at stuff like memory leaks. And stuff like this is still kind of ongoing because this was what I was looking into yesterday. This is response times for this App API service. And the yellow line here, it's kind of hard to see. The yellow lines are the response times here of 2 nodes, and the other ones are of the other 6 nodes. So we can see here that for some reason, the response times of some nodes are 4 times as worse during the peak than the good nodes, which is obviously not nice. And this is probably something that can happen to old school blocking applications as well. But for some reason, we seem to be running into these issues all the time. So just really be careful when you start using this stuff. And monitor, monitor, monitor. So kind of as a summary on our experience with implementing reactive programming and doing reactive programming for 1.5 years. What's the performance of these applications? They're doing pretty okay. They're handling a lot of incoming requests, a lot of outgoing requests, but we were expecting to be able to handle more on a single node. However, we do think we still have a lot of room to improve. So we're satisfied with it. We cannot compare it directly to what if our code was not reactive, not blocking, but we're pretty happy with it. Readability of the code, sometimes better. In other parts where you're doing a lot of business logic and you don't care about types being asynchronous, it's not great. But when you're combining a lot of data, it's pretty good. Debugging. That's something you hear a lot about reactive applications. They're hard to debug. Kinda, but there are some tricks, and you kind of get used to it. So for us, it's okay. Number of unexpected issues. Yeah, we had some unexpected issues. So not great. Future readiness. We do feel like for IO-heavy applications, this is the way to go in the future. So we are happy that we're already using a reactive stack and we can easily adapt to future adaptations. I want to finish off by giving out a few tips on what you can do when you start doing reactive programming. So first one, if you just want to start with this, start from the top. So if you're now using a backspin driver or a blocking HTTP client, just try to rewrite one of them in a reactive way using a non-blocking application. This is most of the time an easy win and an easy way to get used to working with these APIs. And these reactive operators have the functionality to just go back to the old blocking way at any time. So you can really do this part by part. You don't have to migrate your HTTP clients all at once. Use Tomcat 8. So in old versions of Tomcat, there's something about an I/O connector that is still blocking. In Tomcat 8, the default connector is actually non-blocking, and you're going to need that. So we did this by setting some form of sort of Tomcat version in Hira. I might be the default version by now. I don't know. Maybe SRT knows that. But we did this by adding some Hira configuration. Yeah, I already mentioned this. Use optional within reactive types to indicate whether something's not there. We tried a lot of other things, for example, like putting in empty types and having like an empty check, but we just found out that we were actually not doing any checks on these, and we were running into a lot of bugs, and these optional types force you to handle them. So really recommend that. Yeah, I already mentioned this as well. Convert reactive types to ArcJava 1 when using HYSTRIX. Yeah, we converted stuff several times, and then we found out it didn't work. It really doesn't work. HYSTRIX only works for ArcJava 1, So just gonna be forced to use that. Another thing, set the isolation strategy to semaphore. Don't have time to really get into this, but if you don't do this, it's gonna do all sort of thread management for you. You don't want that. Have a performance test ready when you start modifying your code. Like I already told you, we had a lot of weird performance quirks happening, and without a performance test, you're gonna have to do this in production, and you're gonna run into weird stuff. So just have a performance test. It's gonna make your life a lot easier. Finally, a little tip on how to do debugging. So what you're gonna do when you have your nice reactive type in your code, you're gonna put in a breakpoint, and you want to evaluate the value of something, and you're gonna get this. Like, I want to inspect this this variable, but what is it? It's a mono processor with a weight strategy in it. I don't care about this. I just want to inspect the value, see if there's something wrong with a value or something. So there's this nice feature in IntelliJ called evaluate expression that basically allows you to just execute some code at any moment. And all these reactive types, they have a .block method. So using this, you can just do evaluate expression, you take the reactive type, you add .block, and you can inspect the results like you would normally do for any other type. And yeah, this really makes the debugging reactive applications at least a bit easier. Yeah, so a little summary. Reactive, it's pretty cool. I would definitely recommend checking it out, considering it, especially if you're working on an application that does a lot of I/O work, since you can improve your readability and you can improve your performance. But there are still a lot of quirks with it, so be careful. All right, thanks everyone. Questions? Do we have time?
Why don't you just use RX Java 1? Because it does support nulls, and it also supports, like, its default with HYSTRIX.
Yeah. Well, it's end of life. So that's a big thing. We're using RX Java 1 throughout our entire application, and we actually got a lot of nice memory performance improvements from upgrading to Reactor. So we saw that our garbage collection was significantly lower on Reactor. I think they just did a lot of improvements in Reactor compared to RX Java 1, and probably also in RX Java 2 as well.
Any other questions?
Is it worth using Reactive if, for example, your database or your drivers are still blocking?
I'm not that familiar with handling databases in a Reactive application. What my experience kind of is using these reactive types are probably a nice way to indicate that something is asynchronous, even if it is still blocking. But you can still use the reactive types to indicate something. Hey, this is actually doing I/O work, and when I'm using this, before I can use it, the I/O work needs to be completed. But you're not gonna get any of the nice performance improvements because you still need a lot of threads, because most of your threads are going to be blocked by the database calls. Yeah, exactly. Yeah. Yeah.
No more questions, I guess.
Yo, thanks.
Thank you.